Hello everyone, I welcome you all to this channel once again. Today we are going to learn about binomial theorem, a very important chapter for all the class 11 students and all the NDA and JEE aspirants as well. Guys, we know the expansion of a plus b to the power 2. Like we know the formula, it is a square plus 2ab plus b square. Similarly, we can also tell the formula of a plus b to the power 3. This is a cube plus 3a square b plus 3ab square plus b cube. But suppose we are asked the formula of a plus b to the power 4. Then in this situation, I will say I have never remembered, never memorized, never crammed any such formula. Right? We can write the expansion of a plus b to the power 4 by breaking it in a plus b to the power 2 into a plus b to the power 2. But we have never remembered any specific formula for this. Right? So in this situation, we are going to learn how we expand a plus b to the power n, where n is a natural number which is greater than 2, like it can be 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in this picture guys, you can see the face of Blaise Pascal. The binomial theorem that we are going to learn in this chapter, this binomial theorem is formulated by Blaise Pascal. Okay, and also we will also learn about Pascal triangle in this video. Okay, so guys, let's start. Like we had a formula NCR, right? The formula was n factorial upon r factorial upon n minus r factorial. This is the concept which will be required to understand binomial theorem. This will be used here, right? So if you know this formula, then well and good, but if you do not know about this, then we will learn about it right now. Okay, what does this formula represent? Like we have total n elements. Suppose we have total elements equal to n, and elements used at a time that is r. Okay, so this NCR is the combination of n elements taken r at a time. Suppose we have elements a, b, c and d, and suppose we have to select two elements. Okay, then how many combinations can be made? Then we can say there are some combination like a and b, a and b, a and c, a and d, b and c, b and d, c and d. So these are the 6 combinations. Okay, if 4 elements are given to us and we have to use 2 elements at a time, then the total number of combination, total number of selection that we can make are 1, 2, 3, 4, 5, 6. Okay, so without actually writing these combination, we can directly calculate these combination by using this formula. Suppose we have 4 elements and we have to select 2 elements at a time, then according to this formula, we will have to write n factorial, it means 4 factorial, which will be divided by r factorial, it means 2 factorial, n minus r, it means 4 minus 2 factorial, and the answer will be 6. Okay, suppose guys we have to expand 8c1. Then according to that formula, we have to write 8 factorial, 1 factorial, 8 minus 1, 7 factorial. Suppose we have to write the value of 9c2. In this situation, we have to write 9 factorial, 2 factorial, 9 minus 2, 7 factorial. Suppose we have to write the value of 10c4. Then in this situation, we will be writing 10 factorial, 4 factorial, and 10 minus 4, 6 factorial. Okay, and we can solve this expression like 8 into 7 factorial divided by 7 factorial, and the value of 8c1 will be 8. We have 9c2, so this will become 9 into 8 into 7 factorial. In denominator we have 2 into 1 into 7 factorial, and the answer will be 36. Okay, similarly we have 10c4, so we can write this like 10 into 9 into 8 into 7 into 6. And in denominator we have 4 into 3 into 2 into 1 into 6 factorial. So this 6 factorial will be cancelled out by 6 factorial. Now 4 into 2 will be 8. 3 into 9, so 3 into 3, and 7 into 3, 21. Okay, I am leaving the calculation part on you. Okay, so guys, this is how we solve any combination. Okay, this is how we find the value of NCR. Okay guys, these are the basics which will be required to understand how binomial formula is actually formulated. Without them we won't be able to understand the core concept of Pascal triangle. Okay, so this is just a warm-up session just for 5 minutes. Okay, this is just a recall. Suppose we have NC0. There are some standard results that we will have to remember. Okay, like suppose we have NC0, then the value of this will be 1. Suppose we are asked the value of 4C0. So we do not have to use the entire formula once again. Suppose you are using the formula, then you will be writing it like 4 factorial, 0 factorial, 4 minus 0, 4 factorial, and the value of this will be 1. Right? But without using it, we can directly say the 4C0 will be 1, like the value of 8C0, this will be 1, the value of 0C0. The value of 0C0, it means 0 factorial divided by 0 factorial divided by 0 factorial. Again, this is 1. Okay? Okay, the next result that we have to remember, NC1. The value of NC1, this is N. Okay, suppose we are asked 4C1. So this will become 4 factorial, 1 factorial, 4 minus 1, 3 factorial. So the value of 4C1 is 4. Okay. 8C1, we can directly write it 8. 10C1, 10C1. So this will be 10. 1C1 will be 1. Okay. So NC1 will be N. The next result that we will have to remember, this is NCN. NCN. In this situation, N and R both are same. Again, the answer will be 1. These three standard results will be used in the Pascal triangle. Okay. Suppose we have 6C6. You can see both are same. 6, 6. So this will become 6 factorial, 0 factorial, 6 factorial. This is 1. Right? So guys, the value of NC0 is 1, NC1 is N, NCN is 1. Okay? Okay, so let's start binomial theorem. Okay? So guys, suppose we have to write the value of a plus b to the power 0. किसी भी नंबर की पावर 0 होगी तो आंसर 1 होगा. We all know that, right? Okay. Suppose we have a plus b to the power 1. 2 की पावर में 1 will be 2. 3 की पावर में 1 will be 3. a plus b की पावर में 1 will be a plus b. a plus b. Right? Okay. Suppose हमसे पूछा जाए a plus b की पावर में 2. So then this will become a square plus 2ab plus b square. Okay. The value of a plus b to the power 3. Okay. So this will become a cube plus 3a square b plus 3ab square plus b cube. Okay. Guys, you need to notice this triangle. Okay. And observe every number, every term that I have written there. ध्यान से देखिए हर एक टर्म को जो हमने यहां पे लिखी है. The coefficients of a and b, the coefficients of a and b. The coefficient of a is 1, the coefficient of b is 1. Right? The coefficient of a square, this is 1. The coefficient of AB, this is 2. The coefficient of B square is 1. Okay. The coefficient of A cube, this is 1. The coefficient of A square B, this is 3. The coefficient of AB square is 3. The coefficient of B cube, this is 1. Whatever be the power of A plus B, whatever is the power of A plus B, like it is whether it is 0, 1, 2 or 3, their expansion will start from 1 and it will end at 1. 1, 1, 1, 1, right? Okay. 1, 1. Add these two terms. add these two coefficients, you will find 1 plus 1, 1 plus 1, you will get 2, right? Okay, add this 1 with this 2, you will find 3. Okay, add this 2 with this 1, you will get 3, right? You can similarly we can write, suppose we have a plus b to the power, okay, let's write this in another page. Okay, in this binomial, the power of a plus b was 0, the power of a plus b was 1, the power of a plus b was 2, the power of a plus b, this is 3. Okay, suppose this power is represented by n. Let's say this is the value of n. Okay, n, this is n, this is n, this n. Okay, the power of a plus b is said index. The index of a plus b, this is 1, the index of a plus b, this is 1, the index of a plus b is 2, the index of a plus b, this is 3. Okay, when the power of a plus b was 0, the index was 0, it means the value of n is 0, there was only one term, that is 1. Okay, when n was equal to 1, a plus b to the power 1, then in the expansion of a plus b, the coefficients of a and b were 1 and 1, 1 and 1, 1 and 1. When n was 2, in the expansion of a plus b, the coefficients of a square, ab and b square were 1, 2 and 1, 1, 2 and 1. Okay, in NC, when n was 3, there were 1, 3, 3 and 1. You can see the coefficients of a cube, a square b, ab square and b cube. The coefficients are 1, 3, 3 and 1. Okay, fine. So guys, similarly we can write the coefficient of terms in the expansion of a plus b to the power 4. The coefficients will be 1, 4, 6, 4 and 1. अगर आप a plus b की पावर में 4 लिखेंगे तो a की पावर 4, a क्यूब b एक्सपेंड आप उसको जब करेंगे तो उनके जो कॉफिशिएंट्स होंगे वो यही आएंगे. तो ये हम लिख कैसे रहे हैं ये आपको यहां पे समझना पड़ेगा. इनको लिखा कैसे जा रहा है, हाउ आर वी राइटिंग these coefficients. So guys, you need to understand the pattern here. Like in the expansion of binomial, every term they will be having coefficient 1. They will start at 1 and they will end at 1. Okay, 1 पे शुरू 1 पे खत्म. Okay, 1 से शुरू 1 पे खत्म. Starting from 1 ending at 1. Starting from 1 ending at 1. Okay, okay, so now add these two terms. 1 plus 1 will be 2. Add these two terms, we will get 3. 2 plus 1, again we will get 3. Okay, add 1 and 3, we will get 4. Add 3 and 3, we will get 6. Add 3 and 1, we will get 4. Okay, this is Pascal triangle. Okay, suppose we have n equal to 5, then again it will start from 1. It will start from 1. This will end at 1. Okay, then the remaining terms will be 1 plus 4 will be 5. 4 plus 6 will be 10. 6 plus 4 will be 10. 4 plus 1, this will be 5. And the last term, this is 1. Okay, guys, this is the Pascal triangle. Let me make the triangle. So guys, these 1 1 1 2 1 2 1 1 3 3 1 1 4 6 4 1, these are the coefficients of the terms in a binomial expansion. Like in the formula of a plus b to the power 3, this expansion have 1 2 3, there are 4 terms, and the coefficient of these 4 terms are 1 3 3 and 1. Okay, so this relationship between the coefficients was established by Blaise Pascal. That's why this triangle is named after him, Pascal triangle. Okay, so in the Western world they give the credit to Pascal, but I would say before Pascal there were many mathematicians who had already propounded this relation between the coefficients. Like you must have heard about Indian mathematician Maharshi Pingla. Maharshi Pingla, he has mentioned this relation between the coefficients in the form of श्लोकास. श्लोकों के रूप में उन्होंने इसी रिलेशन को, जो ये जो कॉफिशिएंट्स हैं, इस रिलेशन को उन्होंने पहले ही बता दिया. पास्कल गेव दिस थ्योरी इन 17th century, बट उनसे भी कहीं पहले इंडिया में महर्षि पिंगला ने इसके बारे में बता दिया. ओके, बट नॉट जस्ट महर्षि पिंगला, देयर वर मैनी लाइक पर्शियन, चाइनीज मैथमेटिशियन जो इसके बारे में जानते थे, उन्हें ऑलरेडी इसका आइडिया था. ओके, सो गाइज दिस इज पास्कल ट्राइंगल. ओके, इस पास्कल ट्राइंगल को थोड़ा और डिटेल में समझते हैं. ओके, थोड़ा और ट्राई करते हैं और डिटेल में समझने का. You need to observe the pattern. Suppose I try to express every coefficient in terms of combination formula. In terms of combination formula. Guys, n equal to 0. Can we write this one as 0C0? 0C0? The value of 0C0 will be 0 factorial divided by 0 factorial, 0 factorial. Answer will be 1. Okay? Okay. Here n is equal to 1. Okay, so my question is, can we write this one as 1C0? 1C0 and this one as 1C1. 1C1. The value of 1C0 will be, whenever we have 0 in the place of R, the answer is 1. Okay? 1C1, this will be again, it will be 1. Okay, now n is 2. Can we write this one as 2C0? This 2 as 2C1 and this is as 2C2. Right? When n is 3, we can write this as 3C0, 3C1, 3C2 and this is 3C3. Right? Similarly, here n is 4. So this will be 4C0, 4C1, 4C2, 4C3 and 4C4. Similarly, here n is 5. So the value of R will start from 0, 5C0. Then it will start increasing 5C1, 5C2, 5C3, 5C4 and in the last we will have 5C5. Suppose the index of binomial is 6, okay, then n will be 6 and in this situation the coefficients will start from 6C0, 6C1, 6C2, 6C3, 6C4, 6C5 and 6C6. So they will become 1, 6, 15, 20, 15, 6 and 1. And as you can see, again the coefficients are starting from 1 and they are ending at again 1. Okay. So now the summation of 1 plus 5 is 6, the summation of 5 plus 10 is 15, the summation of 10 and 10 this is 20, the summation of 10 and 5 is 15 and the summation of 5 and 1 is 6. Okay, so guys, this is all about Pascal triangle. Okay, so now what is binomial theorem? What is binomial theorem? So let's just understand about binomial theorem. Guys, suppose we have a plus b to the power 2. So the formula for this will be a square 1 into a square plus 2 into a into b plus 1 into b square. Right? Okay. Suppose we have a plus b to the power 3. Then the formula will be 1 into a cube plus 3 into a square b plus 3 into ab square plus b cube. Right? Okay. Suppose we have a plus b to the power 4. Then what will we be writing there? Sir, this is question mark. Okay. So let's just understand this pattern once again. Okay. Since the power of a plus b is 2, so can we write this one as 2c0, 2c1 and 2c2, right? Okay. In the expansion of a plus b, the power is 3, so in the place of 1 we can replace this with 3c0, then this 3 can be written as 3c1, 3c2 and this is 3c3. Okay. Now every term have a, every term is having a, but the power of a is decreasing. Like here the power of a is 2, the power of a, it will start from 2, now it will start decreasing. Like a have power 2, the power of a is 1, but in this situation the power of a is nothing, it means it is 0. Okay. Here a plus b, it is the power of a plus b, this is 3. Okay. So the power of a, the maximum power, this is 3, it will start from 3, then it will start decreasing, 3, 2, 1 and 0. Okay. Now this term is not having any b. Okay. So we can write this like b to the power 0. Now the power of b will start increasing. This term is not having any b, it means there is b ki power mein 0. Now it will start increasing, b ki power 0, b ki power 1, b to the power 2, b to the power 3. Okay. Similarly guys, we can write the expansion of a plus b to the power 4. How? First of all, using combination, since the index of a plus b is 4, so we should write this like 4c0, 4c1, 4c2, 4c3 and 4c4. We will stop at 4c4. Okay. The power of a was decreasing, so first of all we will have the power of a 4, then it will start decreasing, a square, a and a to the power 0. In the first term there will be no b. Okay. And if you are keen to write it, then we can write it like b to the power 0, b to the power 1, b to the power 2, b to the power 3, and in the last we will have b to the power 4. Okay. So guys, this is the expansion of a plus b to the power 4. Okay. Yes sir. Okay. Similarly guys, we can write the expansion of a plus b to the power 5. Using combination, they will start from 5c0, 5c1, 5c2, 5c3, 5c4 and 5c5. Okay. Yes sir. Then in the first term the power of a will be 5, in the next term the power of a will be decreased by 1 unit, so it will be 4, then 3, then 2, then 1 and then there will be no a. Okay. The first term will not be having any b. Okay. So the power of b will be 0, then the power of b will be 1, then 2, then 3, then 4 and in the end the power of b will be 5. So guys, this is the binomial theorem. If we try to write this in general terms, we can say whenever the power of a plus b is n, binomial a and b, a plus b, and the index of a plus b, this is n. Okay. So using combination, we should start this with NC0, NC1, NC2, and it will go on till NCN. Okay. Then first term, the power of A will be n. Like in the previous expansion, the power of A was 5, the power of A was 4. Okay. Then here the power of A will be n. Then it will be decreased by 1 unit. The power of A in the next term will be n minus 1. The next term, the power of A will be n minus 2. And in the last, the power of A will be 0. Okay. We can also say that whatever is the difference between this 5 and 0, this is the power of A. The difference of 5 and 1, this is 4. The difference of 5 and 2, this is 3. The difference of 5 and 3 is 2. The difference of 5 and 4, this is 1. What is the difference between n and r? This is the power of A. Okay. So the difference of n and 0 is n. The difference of n and 1, difference of n and 2, difference of n and n. Right? Then B, in the first term, there will be no B. The power of B will be 0. In the next term, then B will start increasing. Okay. In the next term, the power of B will be 1. Power of B will be 2. And at the last, the power of B will be n. We can also say, whatever be the term, the value of R will be the power of B. The value of R will be the power B. Like R is 0 in the first term, so power of B will be 0. In second term, the value of R is 1, and so is the power of B. In the third term, the value of R is 2, and so is the power of B. 3, 3, 4, 4, 5, and 5. Similarly, in the first term, the R is 0, and the power of B is also 0. 1, 1, 2, 2, and here it is n, so the power of B will be n. So guys, this is our binomial theorem. Using this expansion, using this formula, we can find the expansion of any binomial which have power a natural number. Suppose we have 2 expand 2x to the power 3 and the power of 2x plus 3, it should be a natural number. The power should be, the index should be a natural number. Here we can write 2, 3, 4, 5. It should not be in fractions, in negative. Okay. Suppose we have 5 in the power of 2x plus 3. Then in this situation, this 2x will act as A and this 3 will act as B. So guys, according to binomial theorem, we will have to use combination. So index is 5. So we will write 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. Okay. A is 2x. Then in the first term, the power of A will be 5. Then it will start decreasing. 4, 3, 2, 1, and 0. Right? Then the B is 3. So in the first term, the power of B will be 0, 0. Then it will start increasing. And it will go till 5. Okay. You can also say that the summation of the power of A and B will be always same. 5 plus 0, 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4, 0 plus 5. And this will be equal to the power of the binomial. This will be equal to the index value. The index value in this situation, this is 5. So the summation of the power of A and B will be always, it will be 5. Okay. So now we will have to simplify this expansion. Like the value of 5C0, this is 1. 2 की power में 5, this is 32 x to the power 5. 5C1 will be 5. 2 to the power 4 will be 16 x to the power 4 into 3. Then 5C2 is 10, 8 x cube to 9. And 5C3, this is 10 then 4x square into 27 and 5 2x and 81 1 1 and 2 43. Okay, so now this will become 32 x to the power 5, 16 into 5 80 into 3 will be 240 x to the power 4, 9 into 8 72 x to the power 3, 27 into 4 1080 x to the power 2 and 810x, and in the end we will have 243. So guys, this is the expansion of 2x plus 3 to the power 5. So guys, this is binomial theorem, and this is our Pascal triangle. Okay, so guys, there are some more observations in binomial theorem that we need to know, like the power of n, index is n, then total number of terms in the expansion of a plus b will be n plus 1. Here you can see power is 1, there were total 2 terms. The power is 3, index is 2, terms will be 3. Index is 3, terms will be 4. Whatever is the index, total number of terms will be 1 more than the index. Okay, so suppose we have index value n, the index of binomial is n, then the total number of terms will be n plus 1. Okay, so in the first term r will be 0, in the second term r will be 1, the value of r is 1, in the third term the value of r will be 2. Okay, this is our n plus 1th term, the value of r will be n. Okay, suppose we want to find the value of r plus 1th term. Let's say we want to find the value of sixth term. So in sixth term the value of r will be 5. In the 10th term the value of r will be 9. In the 21st term the value of r will be 20. Okay, whichever be the term, the value of r will be less than 1. Okay, 1 less than the number of term. Like it's 21st term, the value of r will be 20, 1 less. Okay, okay. In first term, the power of a is the difference of n and r. Like the difference of n and 0 is n, the difference of n and 1 n minus 1, the difference of n and 2, this is n minus 2. So here in this situation, the power of a will be the difference of n and 5. The power of a will be the difference of n and 9. The power of a will be the difference of n and 20. Okay, yes sir. Then the power of b will be equal to the value of r. In the first term the value of r is 0 and the power of b, this is also 0. The value of r is 1, the power of b, this is also 1. The value of r is 2 and the power of b, this is also 2. Okay, so guys, similarly the power of b will be 5, the power of b, this will be 9, the power of b, this will be 20. Okay, so let's try to write this in general terms. Suppose there is a term tr plus 1, okay, and we have to write the general term NCR, because this is r plus 1th term, so the value of r will be less 1. Okay, like in 21st term the value of r was 20, in the 10th term the value of r was 9, so in r plus 1th term the value of r will be 1 less than r plus 1. Okay, So here it is r plus 1. So when 1 will be subtracted from here, we will get the value of r. Okay? Yes, sir. Then the power of a will be n minus r. The difference of n and r, and the power of b will be the value of r. Okay? So guys, this is the general term of any binomial expansion. Like we have, suppose we have x plus 2 plus 1 by x to the power 10. If I try to expand this binomial expansion, then I will have total 11 terms, nc0, nc1, nc2 up to ncn, 10c0, 10c1 up to 10c10. Okay, so there is no need to write every term. Suppose we are asked what is fifth term of this binomial expansion. What is the fifth term of this binomial expansion? Then in this situation, guys, we can say the index in this binomial, this is 10. Okay, and we are willing to find the fifth term of this binomial expansion. Then in this situation, we will have to write 10c because we are finding fifth term. So the value of r will be one less than the number of term. Like this is fifth term, so the value of r will be one less than the 5. So this will be 4. Okay, then the power of a, it means a is x by 2. X by 2. Then the power of x by 2 will be the difference of 10 and r, so this will be 6. And the power of 1 by x, this will be the value of r. It means this is 4. You can see the summation of 6 and 4. This is equal to number of index, binomial index 10. Okay. So guys, now we can expand 10c4, 10 factorial, 4 factorial, 6 factorial. Now this will become x to the power 6. This will become 64. Now here it will be x to the power 4. And 10 into 9 into 8 into 7 into 6. 4 into 3 into 2 into 1. So the base same, power subtract, 6 minus 4 will be 2, and in denominator we have 64. The 6 factorial will be cancelled out. 4 into 2 will be 8, 3 into 3 will be 9. So guys, I am leaving the calculation part on you. Okay. So guys, just like as we found the value of fifth term, we can find 7th, 8th, 9th, whatever is the term asked in the question. Okay. In fact, the power of binomial can be, it can be like a bigger number, like it can be 100, 500,000. Okay. We just need to use the general term formula to find any specific term. Okay. So guys, this is binomial theorem and Pascal triangle. Okay. So guys, now we have a concept of middle term in the binomial expansion. Middle term. For example, let's say we have a binomial a plus b to the power 6. Okay, and we are supposed to find the middle term. What should be the middle term in this binomial expansion? Okay, so guys, in this situation, the index of this binomial, this is 6. Index of this binomial, this is 6. Okay, so total number of terms, will be 6 plus 1. It means this will be 7. Okay, total term in this expansion will be 7. Okay, now suppose there are 7 terms, t1, t2, t3, t4, t5, t6, t7. Now what should be the middle term in this expansion? What should be the middle term? एक ऐसी टर्म जो सबसे बीच में है, उसके लेफ्ट साइड में जितनी टर्म्स हो उतनी टर्म्स राइट साइड में होनी चाहिए. ओके, सो आप देख सकते हैं दिस t4 इज द टर्म विच इज फॉलोइंग इन मिडल. ओके, सो फोर्थ टर्म इज द middle term. So now we can find t4. simply by using general term formula, like the power is 6 and in fourth term the value of r will be 3. A is, the power of A is 6 minus 3, difference of 6 and 3, and the power of B will be 3. So guys, this is our middle term, okay? But suppose if the power would have been A plus B to the power 7, A plus B to the power 7. In this situation, index is 7, okay? Then total number of terms will be 7 plus 1. It means that will be 8, okay? So now we have total 8 terms, T1, T2, T3, T4, T5, T6, T7. So guys, there are total 8 terms in the expansion of A plus B to the power 7, okay? And in this situation, in this particular situation, there is no middle term. There is no such term which divide the entire series in 2 parts. In the previous question, this T4 was dividing the entire distribution in 2 parts, like the first half and the second half. But in this situation, there is no such thing, okay? So here, when total number of terms are even, there are 8 terms, then in this situation, there will be 2 middle terms, T4 and T5. These 2 terms will be considered middle term, okay? So guys, T4, fourth and fifth terms are middle term. So guys, first of all, we will find T4. It means 7C3. Then the power of A will be the difference of 7 and 3. This is 4. Then the power of B will be 3. And T5, it means 7C. 5 minus 1, 4. The power of A will be the difference of 7 and 4. And the power of B will be 4. So guys, these two terms will be considered middle term, okay? So guys, ये आप लोग इतना समझ गए होंगे कि हमने कैसे मिडिल टर्म फाइंड किया. बट यहाँ पर तो मैंने टोटल टर्म्स लिखे, ओके? बट यहाँ पे ना हमारे पास एक डायरेक्ट फॉर्मूला भी है जिसके जरिए हम ये पता लगा सकते हैं कि मिडिल टर्म क्या है, ओके? मिडिल टर्म कौन सी है, कौन सी नंबर की टर्म मिडिल टर्म मानी जाएगी. सो गाइस, इफ द पावर ऑफ A plus B is n, okay? The n which is the index of binomial, this n can be even and this n can be odd, okay? When n is even, in this situation there will be only one middle term, only one middle term, okay? Like you can see this example, the power of A plus B was 6 and 6 is an even number and there was only one middle term, okay? But suppose if this n is odd, then in this situation total number of terms will be even, okay? So there will be 2 middle terms. जो हमारा मिडिल टर्म इस सिचुएशन में हुआ करेगा, यहां पर हम सिंपली n को हाफ करके उसमें एक प्लस कर लेंगे और यही हमारा मिडिल टर्म होगा. But when n is odd, then in this situation there will be 2 middle term. The first middle term will be n plus 1 upon 2th term, and second middle term will be n plus 3 upon 2th term. Like we can apply these formulas in these 2 examples. Like the power of A plus B, this is 6, okay? So the middle term should be n by 2 plus 1th term. So put n equal to 6, 6 by 2 plus 1. It means 3 plus 1. 4th term is the middle term. 4th term is the middle term. Same in this situation, the power of a plus b, this is 7. So in this situation there are two middle term. The first one will be n plus 1 upon 2th term, and the second one will be n plus 3 upon 2th term. So put n equal to 7, 7 plus 1, it means 4th term, 7 plus 3, it means 5th term. These two terms will be the middle term in this expansion. Okay, let's take another example. Let's say we have x square plus 2y, x square plus 3y to the power let's say it's 11. Okay, so n is 11 which is odd, n is 11 which is odd. Okay, so there will be two middle terms. In this situation there will be two middle terms. The first middle term, first will be n plus 1 upon 2th term, it means 11 plus 1 upon 2, it means 6th term, and n plus 3 upon 2, it means 11 plus 3 upon 2, it means 7th term. These two will be considered as middle term. So now we need to find T6 and T7. For T6 we will be using formula 11C. The value of R will be 6 minus 1, 5. The value of A is x square. The difference of 11 and 5, this is 6, and then 3y. और इसको आप खुद कर सकते हैं सिंप्लीफाई. ओके, ऐसे ही T7 में 11C, R की वैल्यू 7 से एक कम हो जाएगी. ओके, एक कम हम इसको करेंगे, ये बन जाएगा 6. ओके, और एक्स स्क्वायर की पावर में हमारे पास जो आएगा वो इस 11 माइनस 6 हम करेंगे यहाँ पे 11 माइनस 6, तो ये बनेगा 5 एंड 3y टू द पावर 6 यहाँ पर आ जाएगा. ओके, सो गाइज ये है हमारा यहाँ पे मिडिल टर्म का कॉन्सेप्ट. सो गाइज वी हैव कवर्ड एवरी पार्ट ऑफ बायनोमियल थ्योरम इन दिस चैप्टर. लाइक हमने पास्कल ट्राइंगल हम लोगों ने पढ़ा, हमने बायनोमियल थ्योरम को देखा, उसमें हमने सभी टर्म्स के बारे में हमने समझा, हमने जनरल टर्म्स का फॉर्मा देख लिया, हमने मिडिल टर्म भी यहाँ पे कंप्लीट इधर कर लिया है. सो वी हैव कवर्ड एवरी पोर्शन ऑफ दिस चैप्टर. ओके, सो दिस इज ऑल अबाउट बायनोमियल थ्योरम. ओके, सो मिलेंगे आप लोगों से नेक्स्ट चैप्टर में. ध्यान रखिएगा अपना.